Welcome to our lesson on electric flux for CBSE Grade 12 Physics. Electric flux is a fundamental concept in electromagnetism that helps us understand how electric fields interact with surfaces. It's similar to the concept of water flow through a surface, which we'll use to build our intuition. Let's start with an intuitive analogy. Imagine a stream of water flowing through a surface like a net. The amount of water passing through depends on three factors. First, the strength of the flow or velocity of the water. Second, the area of the surface. And third, the angle between the flow direction and the surface. Now, let's apply this concept to electric fields. Electric flux is defined as the measure of the electric field passing through a given surface. Mathematically, electric flux is represented by the Greek letter phi, and is given by phi equals E times A times cos theta, where E is the magnitude of the electric field, A is the area of the surface, and theta is the angle between the electric field vector and the normal to the surface. The formula we just saw applies when the electric field is uniform across the surface. For a more general case, we express electric flux in vector form as a dot product. Phi equals E dot, where E is the electric field vector and A is the area vector. The area vector points perpendicular to the surface with a magnitude equal to the area. This dot product equals E times A times the cosine of the angle between them, which gives us back our original formula. Let's examine some special cases to build our understanding. Case 1. When the electric field is parallel to the normal of the surface, theta equals 0 degrees, and cosine of 0 is 1. This gives us the maximum flux. Phi equals E times a. Case 2. When the electric field is perpendicular to the normal, parallel to the surface, theta equals 90 degrees, and cosine of 90 is 0. The flux becomes 0. Phi equals E times A times 0 is equal to 0. Case 3. When the electric field is opposite to the normal, theta equals 180 degrees, and cosine of 180 is minus 1. This gives us a negative flux. Phi equals E times A. For more complex scenarios like curved surfaces or non-uniform electric fields, we need to use calculus and integrate over the surface. Phi equals the integral of E dot to here. We divide the surface into small elements calculate the flux through each element, and sum them all up through integration. Electric flux has important applications in physics, especially in Gauss's law. Gauss's law states that the total electric flux through a closed surface is proportional to the net electric charge enclosed by that surface. Phi equals Q enclosed divided by epsilon 0, where epsilon 0 is the permittivity of free space, approximately 8.85 times 10 to the minus 12 farads per meter. Gauss's law is powerful because it allows us to calculate electric fields due to highly symmetric charge distributions, such as point charges, infinite line charges, infinite plane charges. Let's summarize what we've learned about electric flux. 1. Electric flux measures the electric field passing through a surface, similar to how water flows through a net. 2. For a uniform electric field, flux is given by E times A times cos theta. 3. In vector form, flux is the dot product of the electric field vector and the area vector, E dot A4. For complex scenarios, we use integration, the integral of E dot. 5. Gauss's law relates the total electric flux through a closed surface to the charge enclosed. Understanding electric flux is crucial for solving problems involving electric fields and charge distributions in your CBSE Grade 12 exams. Thank you for watching. If you have any questions about electric flux or related concepts, feel free to ask.